4 billion miles from here, a world we were told was dead is doing something no other world in the solar system does. It is cooling itself down, on purpose, with its own sky. And the strangest part isn't that it's happening, it's that one scientist predicted it 8 years ago. And almost nobody believed him. This isn't a rumor, and it isn't a theory anymore. In June of 2025, a team using the James Webb Space Telescope published measurements in the journal Nature Astronomy that confirmed something researchers had been arguing about since 2017. Pluto's atmosphere is behaving in a way that does not match any other atmosphere we have ever studied. Not Earth's, not Mars's, not Titan's. And that matters to us, because the same physics might be quietly shaping dozens of distant worlds we've never looked at closely. It may even be a window into what our own planet's sky looked like billions of years ago, before there was a single molecule of oxygen in it. By the end of this video, you'll understand exactly what Webb measured, why researchers are calling it a genuinely new kind of climate, and why one detail about Pluto's largest moon still doesn't sit right with people once they hear it explained properly. Before we get into it, if you want real space discoveries explained without the clickbait exaggeration, subscribe now, because this is where the actual published research gets broken down first. But to understand what Webb just found, we have to go back, because Pluto's story is stranger than most people remember. An observatory on a hill outside Flagstaff, Arizona. A 24-year-old assistant named Clyde Tombaugh is given one of the most tedious jobs in science: photograph the same patch of sky on different nights, then flip back and forth between the plates, hunting for a single point of light that moved. Most nights, nothing moved. Then, on a plate from February of that year, something did. One tiny dot had shifted against a background of fixed stars. That dot was Pluto. For the better part of a century, it was the 9th planet. And for almost all of that century, we had no idea what it actually looked like. Even the best telescopes on Earth could only resolve it as a blurry smudge. We could track its orbit precisely. It only requires watching where it goes. But its size, its surface, whether it even had an atmosphere at all? Open questions, for decades. Some early estimates badly overstated how big Pluto was, because astronomers assumed it had to be large enough to explain small wobbles in the orbits of Uranus and Neptune. Those wobbles were later found to be measurement errors. Pluto had nothing to do with them. So for generations, most of what the public believed about Pluto was guesswork stacked on guesswork. Then in 2006, the International Astronomical Union voted. Pluto was reclassified as a dwarf planet. It remains the only world in recorded astronomical history to be discovered, celebrated, and then formally voted out of the category that made it famous. And for a while, that felt like the end of the story. Small, distant, irrelevant, easy to file away. That assumption did not survive contact with real data. July 2015. After 9.5 years and roughly 3 billion miles, NASA's New Horizons spacecraft closes in on Pluto at more than 30,000 miles per hour. And here's the part people forget. It had exactly one chance. No orbit, no second pass, no slowing down. Just a narrow window of a few minutes to grab everything it possibly could before continuing on into the dark of the Kuiper belt forever. What it sent back rewired everything. A vast, pale, heart-shaped plain stretching across the surface, smooth and strangely young-looking compared to the ancient, cratered terrain around it. Mountains of solid water ice rising more than 10,000 feet. At those temperatures, water ice doesn't behave like ice. It behaves like bedrock. Fields of frozen nitrogen appearing to churn in slow convection cells, a sign of heat and motion beneath a crust everyone had assumed was completely dead, and layer after layer of blue haze, rising hundreds of miles above the surface, glowing when backlit by the sun. Pluto didn't look like a leftover chunk of frozen rubble. It looked like a world, still in the middle of becoming something. But New Horizons kept flying. It captured what it captured and vanished deeper into the outer solar system, never to return. Which means everything it didn't answer stayed unanswered. Scientists spent years arguing over that data and building models they had no way to test. What they needed wasn't a better photograph. They needed a way to read Pluto's chemistry directly, from billions of miles away, without ever sending another spacecraft. And in about 3 minutes, I'll show you the specific measurement that finally made that possible, because it's not the one most people expect. Here's what makes the James Webb Space Telescope fundamentally different from a spacecraft like New Horizons. Webb doesn't fly past anything. Webb doesn't take a snapshot. Webb reads light itself. It splits incoming light into individual wavelengths to reveal the chemical fingerprint of whatever it's staring at. Point it at a faint pinprick of reflected sunlight 4 billion miles away, and it can tell researchers which molecules are present, how warm different layers of an atmosphere actually are, and how that atmosphere is changing over time, without going anywhere. But there was a problem. And this is the part that had blocked researchers for years. From our point of view, Pluto and its largest moon, Charon, sit extremely close together in the sky. so close that separating their individual heat signals was, for earlier generations of telescopes, effectively impossible. Teams had tried to detect exactly this signature before Webb launched. They kept coming up empty, not because the signal wasn't there, because their instruments couldn't tell how much of the detected heat was coming from Pluto, and how much was bleeding in from Charon sitting right next door. Webb's much larger mirror and far more sensitive infrared instruments finally solved that specific problem. Starting in 2022, once calibration was complete, Webb turned toward Pluto. And what came back wasn't a prettier picture. It was closer to a diagnosis. If you're the kind of person who wants this stuff explained clearly instead of buried under jargon, drop a like right now. It genuinely helps this reach more people who'd actually enjoy it. Now, the first major finding. And it starts with that same blue haze, New Horizons, photographed back in 2015. Researchers already knew Pluto's thin atmosphere was wrapped in a delicate shroud of hydrocarbon particles. What nobody had confirmed was what that haze was doing to the world underneath it. In 2017, a planetary scientist named Xi Zhang, working at the University of California, Santa Cruz, proposed something that sounded backwards to a lot of his colleagues. Look at Saturn's moon Titan. Titan is also wrapped in atmospheric haze, and there the haze traps heat. It warms the world below it, like a blanket. Zhang argued Pluto's haze might be doing the exact opposite. His idea: the haze particles absorb sunlight during the day, then radiate that energy straight back out into space as infrared heat, faster than Pluto's incredibly thin atmosphere could ever hold onto it. Not a blanket, a radiator, actively bleeding heat away from a world that already had almost none to spare. At the time, this struck many of his peers as unlikely. Critically, there was no instrument in existence sensitive enough to test it. So the idea sat there for 8 years. Then Webb's mid-infrared instrument came online, and for the first time, Pluto's faint thermal signal could be cleanly separated from Charon's. A team led by astronomer Tanguy Bertrand at the Paris Observatory used it to measure Pluto's atmosphere directly. The results were published in Nature Astronomy in June of 2025, and they confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the haze particles suspended inside it, and it measured roughly 30 degrees Fahrenheit, colder than earlier models had expected. Researchers now describe this as a genuinely new kind of climate, one that behaves differently from every other atmosphere we've studied anywhere in the solar system. Sit with that for a second. Pluto isn't simply cold because it's far from the sun. In a very real sense, Pluto is refrigerating itself, and scientists are still working out how far the consequences of that actually reach, including whether similar hazes might be quietly shaping the climates of other distant worlds like Neptune's moon Triton, or whether it hints at what Earth's own sky looked like billions of years ago, long before oxygen ever built up in it. But that's not even the strangest part of what that haze is doing. There's a second discovery tied to the exact same haze. It's quieter, and honestly, it's stranger once you understand it. Even the incredibly faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high in its atmosphere. Those broken fragments don't just vanish, they recombine into heavier compounds, a slow chemical cascade that eventually produces reddish-brown particles called tholins. And those particles drift down and settle onto the surface. New Horizons caught early traces of this in 2015. More recent observations have refined how it works. Here's the detail that tends to stop people. Tholins belong to the same broad family of organic molecules that some scientists believe may have once rained down onto the early Earth, potentially contributing raw material toward the chemistry that eventually led to life here. I want to be precise about that, because this is where a lot of channels overreach. This is not evidence of life on Pluto. Nobody is claiming that. What researchers are saying is that Pluto is running the chemistry, the ingredient stage, continuously. And it's been running that way for roughly 4 billion years. A slow, endless snowfall of organic building blocks, landing on a surface far too frozen for any of it to ever spark into something alive. To understand how extreme that cold actually is, look at the raw numbers. Sunlight reaching Pluto is roughly 1,000 times fainter than sunlight reaching Earth. High noon there would look like heavy twilight here. Surface temperatures generally sit somewhere between about minus 387 and minus 369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At those temperatures, nitrogen, the same gas making up most of the air you're breathing right now, freezes completely solid. The atmosphere you're standing in on Pluto would simply become part of the landscape. And there's a reason researchers care so much about this beyond it being strange. Scientists studying the origin of life on Earth have argued for decades about where the first organic building blocks came from. Did they form here? Or did at least some of that raw material arrive from space, delivered by comets, asteroids, or slow chemistry running in cold, icy environments? On Earth, that process finished playing out billions of years ago and left behind only indirect evidence. On Pluto, it's still running, right now, today, which gives researchers something they otherwise could never have: an active natural laboratory for the conditions that existed before life began anywhere. Pluto isn't a curiosity. It may be one of the closest working models we have of the chemical stage that came before biology. And that's still not the finding that unsettles people most. The third major finding is the one that tends to change how people picture this whole system. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through the thin atmosphere, slip past Pluto's weak gravity, and escape outward. Scientists already suspected this. That part wasn't new. The question was, where was all that escaping material going? Because it wasn't simply dissolving into empty space. Something was catching it. Meet Charon, Pluto's largest companion. A battered ice moon roughly 750 miles across, locked in an unusually tight gravitational partnership with Pluto. Most of Charon's surface is fairly unremarkable. Ancient, cratered water ice. Except at the poles. The poles are stained a deep, unmistakable reddish brown, darker than anything else on the moon. For years, researchers suspected a connection between that stain and material escaping from Pluto. They just couldn't confirm it directly. And the mechanism turns out to depend on Charon's absurdly long seasons. Because of the way Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades in complete darkness. No sunlight at all during that stretch. That makes the pole an extraordinarily effective cold trap. Escaping methane molecules drift across from Pluto, arrive at that pole, and freeze solid onto the surface, simply because there's no warmth anywhere to keep them as gas. And then they sit there, accumulating, for years. Then sunlight finally returns to that part of the moon, and it does not melt the methane away. Instead, ultraviolet radiation and cosmic rays break those frozen molecules apart and reassemble the fragments into heavier, redder, more complex compounds, essentially locking that dark color into the surface permanently rather than letting it evaporate back into space. Earlier research, including a widely cited 2016 study, laid out this full chain. Methane escapes Pluto's atmosphere, crosses roughly 12,000 miles of space separating the two worlds, gets captured by Charon's gravity, freezes onto its cold polar surface, and gets broken apart by radiation into the same family of heavy organic compounds that colors Pluto itself. Two worlds, locked together, trading atmosphere and color in a slow exchange that has apparently been running since long before either one had a name. And Charon had one more surprise waiting. In October of 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm something new on Charon's surface. Two things, actually. Carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to clean a wound, both frozen directly onto the surface of that moon. According to the published research, the carbon dioxide most likely came from underground material exposed by impact craters, meaning something punched through the crust and revealed what was underneath. The hydrogen peroxide appears to have formed differently. Years of radiation striking Charon's water ice, breaking it apart, and rearranging it into something new. Researchers noted this specific combination had never been confirmed on Charon before, which adds another layer to a moon that keeps turning out to be far more chemically complex than its plain, icy appearance would ever suggest. If you're finding this as strange as I did while researching it, drop a comment. It genuinely helps me figure out which space stories are worth covering next. Now picture what it would actually be like to stand on Pluto's surface, because the details are hard to imagine otherwise. The sun is still visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length. No warmth, no glare. You could look directly at it without any discomfort at all. The sky around it sits in a permanent grayish-blue gloom, thick with haze, never fully day, never fully night, just unchanging dimness. The ground under your feet behaves nothing like ice does here. At nearly 400 degrees below zero, water ice stops being slippery. It behaves like rock, hard enough to ring almost like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, offers nothing to breathe, though realistically the cold would reach you long before the thin air became the immediate problem. And overhead, fixed permanently in the same spot in the sky, Charon hangs there, unmoving. Because the two worlds are close enough in size that they don't orbit each other the way Earth orbits its moon. They orbit a shared point in empty space between them, locked so tightly that each one always shows exactly the same face to the other. A silent standoff running for billions of years, and the surface holds its own mysteries. In a region researchers named Tartarus Dorsa, New Horizons photographed something never documented anywhere else in the solar system. Tall rows of jagged ice blades, some reaching more than 1,500 feet high, made of frozen methane, arranged in long parallel ridges, like a field of frozen knives. Similar formations exist on Earth, in certain high-altitude deserts, where they are called penitents. But ours rarely grow taller than a person. Scientists believe the Earth versions form through uneven sublimation, sunlight carving away lower areas faster than higher ones, gradually sculpting the ice into blades. On Pluto, that same basic process appears to have played out on a vastly larger scale, over a far longer stretch of time, using frozen methane instead of water. And a 2025 analysis of the original New Horizons data suggests these blade fields may wrap around as much as 60% of Pluto's equator, an entire ring of jagged frozen terrain circling the dwarf planet. Elsewhere, a dark region roughly the size of Alaska stretches across the equator, colored a deep reddish black, where those falling tholin particles have piled up thickest over billions of years. And south of that famous heart-shaped plain, two enormous isolated peaks rise out of the landscape that researchers still cannot fully explain. One stands roughly 13,000 feet tall. The other may reach close to 20,000, with a base wide enough to rival some of the largest volcanoes on Earth. Both have deep depressions at their summits. Both are ringed by fractures. Both have lumpy, uneven flanks that closely resemble cooled lava flows, except there is no molten rock on Pluto. If these features are what they appear to be, they are cryovolcanoes. Structures that once erupted, not with melted stone, but with a thick slurry of water, ammonia, and methane, forced upward from somewhere deep beneath the crust. Researchers remain divided on exactly how they formed. A handful of massive eruptions, many smaller events over a longer span, but either interpretation points toward the same conclusion. Something, at some point in Pluto's relatively recent geological history, was warm enough beneath that frozen shell to push liquid material all the way to the surface. Which raises a genuinely unsettling question: what's still down there? That internal warmth leads directly to the most debated idea surrounding Pluto today: the possibility of a hidden ocean, buried roughly 100 miles beneath the surface, kept liquid by the slow radioactive decay of elements inside Pluto's rocky core. I want to be clear about what this is and isn't. Nobody has photographed it. Nobody has confirmed it. This is a hypothesis, and researchers themselves describe it that way. The evidence isn't an image, it's a pattern. Cracks and ridges across the surface line up in ways consistent with a subsurface layer of liquid water shifting slowly beneath the crust. And that famous pale heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be concentrated underneath. Here's why scientists find this so compelling even without direct proof. Similar hidden oceans are already strongly suspected beneath Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons. Enceladus even vents water vapor directly into space through cracks near its south pole. But those are moons being flexed and heated by enormous parent planets. Pluto has no such parent. Pluto is small and cold and alone out there. So if Pluto is hiding an ocean, it would suggest buried oceans might be a far more common feature of icy worlds across the outer solar system than anyone assumed. Not a rare exception, limited to a few well-studied moons close to the sun. And if that ocean genuinely exists, it has likely been sealed there for billions of years. No sunlight, no radiation. Fed only occasionally by hydrocarbons seeping down through cracks in the ice above, under enormous pressure, in total isolation. One of the strangest possible environments in the entire solar system. No one can say for certain whether it's there, and right now, there's no way to check. Because here's the frustrating truth. There is currently no funded mission planning to send anything back to Pluto. No lander, no orbiter, nothing in the books. And it isn't because scientists lost interest. Missions to the outer solar system are extraordinarily expensive and extraordinarily slow. Often a decade or more of travel before a spacecraft even arrives, followed by a single brief window to collect data exactly like New Horizons had. Space agencies have to weigh that against missions closer to home that return results in a few years instead of a few decades. Distant icy worlds usually lose that argument. So for now, Webb is our only working tool, quietly checking back in every few months whenever Pluto swings into its field of view, adding another data point each time, and almost always making the overall picture stranger than it was before. Here's the detail that sticks with people longest. Pluto isn't special because of where it is. It sits inside the Kuiper belt, a vast ring of icy debris beyond Neptune, home to hundreds of thousands of objects wider than about 60 miles, plus an estimated trillion or more comets. A handful of other bodies out there, including Eris and Makemake, come reasonably close to Pluto's size. And beyond the Kuiper belt lies the theorized Oort cloud, thought to hold another trillion icy bodies, stretching outward a meaningful fraction of the way toward the nearest star. To put that in perspective, the Kuiper belt alone spans a region of space hundreds of times larger than the asteroid belt between Mars and Jupiter, the one most people picture when they imagine a field of space rocks. But unlike that inner belt, which we've mapped in fairly close detail, the Kuiper belt remains almost entirely unexplored. Exactly one spacecraft, New Horizons, has ever gone deep enough to photograph any of its residents up close, and it managed close flybys of just two objects, Pluto and a small distant body nicknamed Arrokoth. 2 out of hundreds of thousands. So if Pluto is genuinely cooling its own sky, bleeding its atmosphere onto a companion moon, and possibly hiding a liquid ocean under a shell of ice, there's no obvious reason to assume it's the only object out there doing any of this. It's simply the one close enough and bright enough for our current instruments to actually study. Everything else across that enormous region remains nearly unobserved. So what does all of this add up to? Pluto was never the dead end of the solar system that a single vote in 2006 made it seem like. It turned out to be the beginning of a whole set of questions scientists are still learning how to properly ask. And if one small, frozen, formerly demoted dwarf planet was hiding this much complexity underneath its surface, it's genuinely worth wondering what all the others are hiding too. If this shifts how you think about the outer solar system, hit subscribe and turn on the bell, because Webb is still pointing back at Pluto every few months. And there's a real chance the next round of data adds another strange piece to this puzzle. And if you want to understand the other world out there that might be hiding an ocean, the one that's actively spraying it into space through cracks in its ice, watch the Enceladus video next. That one gets even harder to explain. Thanks for reading. I'll see you in the next one.